are going to continue sketching. And you're saying to me, but Mrs. Ford, I already know how to do that. What is different? They're not factored. Exactly. So, as long as they're factored, it's pretty easy. You just put the dots on there and draw the squiggly lines. But if they're not already factored, then that becomes your first step. You have to factor it. So, these guys have a bunch of terms. How do we factor something that has a whole bunch of terms like that?
They do half factor.
We split the equation in half and divide it down.
We call it factoring by grouping. Right? Pay attention. So I'm going to take these two terms, and what can I factor out of them?
X squared.
So just the first two, I can take out an x squared and be left with x minus 4. Now, what about the last two? What can I take? What? Negative 1. And what will that leave me with? A positive x and a negative 4. Now, kids, if you are factoring by grouping, you must end up with the same parentheses. Now, just a little hint, what's to come. Not every problem can be factored by grouping. And you'll know it because you can't get a matching parentheses. Now, as soon as you get a matching parentheses, you write it down, and then you write down everything that's not the matching parentheses. So that would be x squared minus 1. And then what do we know about x squared minus 1?
X plus 1, x minus 1.
It is the difference of squares, x plus 1, x minus 1. That is exactly right. So now we are ready to graph. Because now it looks just like the other ones we did look, right? So what do? We put some dots on our number line. And where will the dots, or on our grid here, our x-axis, where will the dots be? At positive 4, negative 1, and 1. Alrighty. Now, how many x's do we have? We actually knew from the beginning this is an x cubed. So how should this one start? Where should it start? Down? Do I have any bouncing or anything going on here? So it's going to start down here. And isn't it just going to pass through all of them? And there it is. That's not that one. That is this one right here. Everybody okay with that? Now, before I erase this, I want you guys to look at this equation and be proud of yourselves because you just graphed that equation. That's a big, scary equation. That's right. Good job. That is exactly right. All right, let's try this one. Let's try this one. Here we go. Same thing. In order to sketch it, it must be factored. Okay? So, Toby, can you begin the factoring process?
So you would do the grouping problem. So you would take out x squared for both of them, and then you would get x plus 3.
Beautiful. Perfect. All right. Now, Hannah, what's going to be the second part of that?
You gotta take out 4.
Actually, I think I'll take out a negative 4.
And then you're left with x plus 3.
X plus 3. Yep. And there it is. That's what we have to have happen. We have to have that common parentheses. Did I put a squared or anything on it? No. I just wrote it down. X plus 3. And then in parentheses, I'll have x squared minus 4. Right? And Logan, what about x plus 4 or x squared minus 4? Can I do anything with that?
Oh, you can factor it, make it x plus 2, x minus 2.
Exactly. It's called the difference of squares. Is everybody okay with that so far? What? Everybody got it? Follow all that? Kyla, you all right?
Yes.
Okay. So I'm going to have dots where? -3, +2, and -2. Ready? Am I bouncing anywhere or doing anything weird with these dots? No, because you don't have anything squared. So we're going to start down here. How do I know I'm starting down? Because it's an x cubed. And that's what x cubes look like. Notice I just went straight through. What do you think, people? Not bad. Let's try one more. Then we'll get some excitement going. Here we go. We're going to sketch this guy. All right, Tex, what do you think? Your job is to draw a picture of this.
Right. First, one factor.
Yep. Oh, how are you going to do that?
You take a 2 out.
Of what? The whole thing?
Yeah.
Oh, okay. We can take a 2 out of the whole thing. Now, I took a 2 out of the whole thing. That's okay. That's fine. But I'm not done factoring at all. Now I gotta group it. Now, somebody might think, oh, well, while you're taking out a 2, why don't you take out an x? You can't, because there isn't one on the end. So, you don't want to take it out of 3 terms. You want to take out anything that can come out of the whole thing, that's fine. But after that, you're going to factor by grouping. So, I'm going to just bring this 2 along for the ride. He's just there. In fact, you know what? I'm not even going to write him because I'm afraid it'll get confusing. Let's forget about him for a minute. What can I take out of here? X squared, leaving me with x minus 1. What about here? -4, leaving me with x minus 1. We took out a negative. So my common factor is x minus 1, and then I have x squared minus 4, which is x minus 1, and then plus 2 minus 2. And then don't forget that 2 we took out in the beginning. We can put him back in there. And I do think taking that 2 out was a good idea. I just don't want it to confuse you at all. So let's graph. Now you've got a factor. So now you should be able to sketch that. Where do my dots go? My x-intercepts?
1, -2, and
1, -2, and 2. sketch it in? Where are you gonna start? Down here? This is a cube. Cubes start down and end up. That's what cubes do. So it starts down here. Does it have any bounces or anything? Nope. How do I know there's no bounces? No square factors, right? Now I know what you're thinking. You're thinking, oh, Mrs. Ford, you told me this was going to be so exciting. And that's really not that exciting. Look at this one. This is when things get exciting. At first glance, you're like, wait a minute, it doesn't look any different than the other ones we've done. And you're right, it doesn't look any different. So go ahead and let's factor it.
You're not gonna get the same in parentheses.
Some of you are already noticing that this is not going to factor by grouping. Because if we take out an x squared, we'll have x plus 2. But what are you doing there? Taking out a negative 1? Well, that's great, except they don't match. So what do? We are going to use
Formula.
a couple of very, very important theorems. Here's what I want you to understand. If I have something that is a factor, so if I tell you that 5 is a factor of 15, you would say, yes, you're right. But how do you know? What does it mean to be a factor? So 5 times something is 15, or 15 divided by 5 goes in evenly with no remainder?
Yes.
So if something is a factor, it divides in with no remainder. You'll agree with that statement, right? So here is what we do. We start guessing numbers, and yes, it is a guess. We start guessing numbers, dividing them in to this guy, and hoping that there is no remainder. Now, Mrs. Ford, how do I divide into that? Well, last year, you learned something called synthetic division. Does that sound familiar to you?
I don't know.
Can I opt out?
You blocked that out of your mind? It's real easy. Here's how it works. Listen, here's how it works. I want you to take all of the numbers, no letters, and write them down. So 1, 2, -5, -6.
Not this.
And then out here in a box or some kind of little shape, I use a box, you may have used something else.
I remember that.
I'm going to pick a number, I'm going to pick a 1. I'm just going to pick a 1. Then, that's a guess. That number's just a guess. Because remember, I have to guess things that are going to divide in and leave no remainder. That's my goal. So then, I'm going to leave, I'm going to draw a line there, but I have to write in here, so use some space. And then this number, whatever it is, always comes straight down. So remember, these numbers came from the problem. This one I guessed. That first number, whatever it is, gets dropped straight down. Now, I take 1 times 1.
Equals 1.
1 times 1 is not 2. 1 times
Oh my
1
God.
is 1, and I write it right here. Then I add these. Is this starting to come back to you? And then 1 times 3, I write it here, and I add those. And then 1 times negative 2, and I add those. Well, actually, I didn't find a factor because this last number right here is the remainder of the division. And I want that to be a 0 because if I have found a factor, then the remainder is 0. So you just did a division problem. This is called synthetic division. You just did a division and found out that when you divide 1 into that thing, the remainder is negative 8. It is not a factor. Remember, we're trying to find factors so that we can graph it. So now I'm going to do exactly the same thing. I'm going to pick a different number. So maybe 2. Oh, potentially it could, but I do have a little hint for you that I will share.
It's got to factor in the big number first.
But for now, we're just guessing. This is our first problem. I don't want to give you too much information. So there are the numbers from the problem. This time I'm guessing 2. So this number, remember, always comes straight down. That's how you get started in the process. So 2 times 1 is 2. Add them and I get 4. 2 times 4 is 8. Add them and I get 3. Oh, you're starting to get excited. 2 times 3 is 6. And add them and you get 0. Now, what that means is that one of the dots is at 2. That number is a factor. That means there's a dot at 2 on your graph. Now, Jalen says, wait a minute, Mrs. Ford, there's got to be 2 more out there, right? Because this is an x cubed, so there should be 3 dots. All you need to do now is recognize that this is x squared plus 4x plus 3. Because when you did the division, it started out as x cubed, but you divided an x out of it, this one. And so now it's x squared plus 4x plus 3. And that factors, you don't need any tricks. You can do that one. How does that factor? X plus 3, x plus 1. Wait a second. Let me finish this and then we'll come back to it. That means, where are the other 2 dots?
Negative 3 and negative 1.
At negative 3 and negative 1. Now, before I answer Izzy's question, 2 things. That means that when I was guessing numbers, I could have guessed negative 3 and that would have worked, or negative 1 would have worked. I just happened to have guessed 2, but whichever one you find, when you get it divided out, the leftover part here, you can just break down into the factors. You don't have to continue the process. The second thing is, we need to finish the sketch. So it was x cubed.
Yeah.
Nothing is bouncing or anything, so my sketch is just that.
I don't understand, how'd you figure out that it was, for the, x squared plus 4x plus 3, how'd you figure out that it was x squared?
Okay, it's always 1 less than the original. So the original problem was x cubed.
Yeah.
So Sam, when I take a number out of that, it drops it down a degree. So it drops it down to x squared. If it had been x to the 4th, then it would drop down to x cubed.
Now, 4x.
Yeah. Yeah. Does that make sense to you?
Wait, so that was kind of my question. So like, so like the two, just taking
Yes. If you get 0 on the end, if you get 0 on the end, you know what? This has never happened before. Look what time it is, and you're not all running out the door. I love you, love you, love you, people. I told you this was kind of exciting.
Well, is there no, because you're gonna be guessing, you could be guessing numbers for hours.
You could be.
But is there